Okay. Now the other guy is going what's this force?
It's 10 as well, I thought. Yeah,
10 newtons. And what's the angle?
40.
40 degrees down. Okay. So let's calculate these components.
Horizontal is 7.60.
60 newtons, yep.
And vertical 6.42. Did anyone else do it? 7.1.
I think you're right. I did it yesterday. Okay, so now, what do I see? Well, I know for sure it's going to go to the right, don't I?
Yeah.
This guy's pulling slightly up at 5 newtons. This guy's pulling slightly down at 6.428 newtons. So it's going to move down a little bit that way. So let's use a right triangle and find out how much. So I go like this, and this is my applied force. Okay, so .66 and 7.66, that's 16.32. In that direction, right? And he's pulling 1.428 newtons down. Okay, so what's his force applied then? No. Square this, square that, take the square root of it. 16.38, bless you, 2 newtons. And then I have to find that angle. Not 6. Alright, so now you gotta find that angle.
Yeah, it is 5 degrees.
So it's going right, 5 degrees right on the nose.
What was it, 5.006?
006.
Sorry, 5.0006.
Alright, so we'll just put 5 degrees down, like that. Okay?
Can I have my phone quick?
Yes, you can.
Thank you.
Alright? Okay, so that's my applied force. So how do you find, the question asks you what's the acceleration, right? So you've got to find it by acceleration is equal to your applied force minus your force of friction divided by the mass that you're pulling.
We just rearrange that thing, okay?
Right? Because that's net force equals applied minus friction. Alright? So your answer has to be this, and at the end of it, I need to see this. Okay? This is a note for everybody in here. When I ask you for an acceleration at the end of this question, which is what I'm going to ask you, you have to show me the angle at the end. There are so many questions that you are doing right now in your tests with vectors that you're not putting directional units on it. You have to show direction on every single vector question. There's not a vector question in which you don't show angle. And it needs to be as part of your final answer. Don't just put it in there and then leave it so I have to find it. I want to see that as your final answer. Acceleration, because acceleration is a vector quantity. So you need to show the direction on it. There, I would say 80% of you are not putting directions on your final answers. You have to show them. Go ahead.
It's kind of the same question, but it's a tad different. It's this one right here.
I'll come back to that
Okay.
as soon as I'm done here. Okay, a second thing I want to point out to you. Every question that we have done on the board this year so far has been put onto video. I am posting, this is the only class I post everything. Okay? So if you're stuck with a question, go through the videos and look if I've covered it. And I've actually labeled it better than I have ever labeled in any class. I'm putting page numbers, question numbers, they are all on there. So when you're going into Edmodo, you should be able to find anything that we did on the board that day will be on that. This is the only class I'm posting everything. Okay, so you have every question on there. So if you're still stuck at home, go on to Edmodo and find out where we did that question, because it's probably been asked. Alright? Okay. Sam, are you good?
Yeah.
What part of this, just a second, Morgan, what
Okay.
part of this did you have trouble with?
Well, I did it, like I could do it, but it just was so hard. It's hard remembering what step to do next.
Okay, so
Mostly making.
separate your two triangles.
Yeah.
Alright? And what I'm trying to do is I'm trying to find my applied force.
Okay.
And to do that, I need that third triangle. But I'm going to change this for this next question. Okay? Because this one I'm going to do with right triangles. I'm going to do this one with right triangles because I'm given both those angles. The next one I'm going to do, you're not given both the angles, you're given the angle of separation between them. That changes how we do it. Okay, Morgan, you have a question about this?
This is a little bit of a dumb question, but I forget. I was almost done the question, and the one thing I forgot is how to get that angle. Like, I know it's sine
Okay.
negative.
No, it's not sine negative. That's where your issue is. Okay? Now, it can be sine negative if you're going to use this, Morgan, but I would prefer you don't use this because you're solving for it. I mean, you solve for everything here. But what I would use is the green here. Opposite over opposite over adjacent, which is tangent.
Yeah.
Okay? So to get that angle, tan alpha is equal to 1.428 over 16.320. Okay, Morgan?
Okay, so
So use your tan and use these guys. You could use sine. If you're using sine, Morgan, you got to use this guy and that guy.
okay.
I bet that's where your error is. Okay?
So you're recommending just use tan?
Yes. Every time.
Okay, before I stop, I want to see if my calculator will do it because
Okay.
I sometimes will need keystrokes for everything.
Yeah, that's fine. Okay. Did you get 5 degrees?
No.
Okay, here's your keystrokes, Morgan.
Okay.
Tan negative 1, so second function tan, right?
Yeah.
Okay? I gotta see what, 1.428. Do you have brackets? Does it open a bracket when you do second function tan?
No, I have to insert the bracket myself.
Okay, so then do that now, right
Okay.
there.
I made sure to do that.
Divided by 16.320, close equals.
Yeah, I got 5.
You're good now?
Yeah, it worked.
Okay,
I'm good.
good stuff. Alright. Anybody else have a question? You obviously, we've seen this enough times that we're gonna have to do this again. So you need to know how to do that question. Is there anybody that has an issue with this? No? Okay, I'm gonna show you the second way that they can ask this question. So, instead of giving you the individual angles, they're giving you the separation angle. Alright. When I'm drawing vectors, how do I draw the addition of two vectors, what do I have to do?
Tail to, end to tail, or no, yeah, tail to.
Okay, tip to tail. That means if I'm going to add these two vectors together, I need to draw one of them, okay, at the end of the other. Alright? So, I'm going to do this, I can do this one way, or two ways. I can move this guy or move that guy. I'm going to move this guy, right here. So right now what I'm going to do is I'm just going to do this up here. I'm going to draw, actually, I need to move this down. Sorry. Okay, so I'm going to take this guy. And I'm going to move him right to here. Okay? So all I've done is taken this guy and moved it right to here. Now, what do I know? Well, if I extend this one, okay? What is this angle right here going to be? It's going to be 40. That's going to be 40 degrees right there. Okay? Now, alright? Now, what does that make this angle right here then? This guy right here. This guy right here. What is that? 120? It'd be what? 140, right? Because this and this add to 180. So this makes this angle right here 140 degrees. That's the catch in the question. Now, what I do is I just get rid of this here, and I need to find that right there, and then that angle. Okay, so my 80 newtons is now right here. Alright? This one I don't use right angle trig. Just like the last section where I had an airplane question where I couldn't use right angle trig, I need to use law of cosines. This is one of those guys as well. I have to use law of cosines for it. And then I need law of sines to find my angle. Alright? Okay, so at that point then, that squared plus that squared minus 2 times the cos of 140 square rooted. Alright? But drawing it, I took this guy right here and moved it right to there. Now I can also do that with this guy as well. I could have done it with this guy. I just choose not to because I think right angle trig's easier for most people. But I could also have done that. I could have moved this guy right to there and then figured out my angles at that point. Yes, Brendan?
For this question, could you also just find, like, if you look at that, could you just find this side, how
No.
many newtons that is, and then,
You would get it, yes. You would get the FA prop correctly,
okay,
but you'd have no chance of getting the
angle.
angle. The reason you get that properly is because you're still using 60 and 80 and 100. Sorry, I lied. You can't do it that way because your angle is going to be 40 instead of 140. You need to have 140 there, not 40. Right? Because if you use this, that's 40 degrees, so you can't do it that way. Why? Because when you have tail to tail, that's actually subtracting the vectors instead of adding the poles together. Okay? So you have to move that in order to do that. Okay?
Would it matter which area you move? Like you could.
No,
do
I could have.
60 to 80.
I had said that as well already. Okay? I could have done this as well. And move that guy to here, make that 60 newtons. This is still 80 newtons here, right? But that would still be 140 degrees right
How
there.
did you know to do that way instead of the other way?
I don't, I can do either one.
How?
Like, or what do you mean, method-wise?
Yeah, instead of the one you just.
Because,
did.
because this angle was given to me as 40, it wasn't broken up.
Oh.
You can't assume that that's 20 and 20. You could, if these two were pulling at the same force, then you can assume that it's 20 and 20.
Okay.
But because they're pulling at different forces, you can't do that. So that's a no. That question there, how did I know that 40 degrees in here wasn't 20 and 20? Because the two forces were not the same. If they were the same, then you could assume that they were 20 and 20, and you could do it the same as the last question. All right? The other question was, how come I moved this one up to here? Just because I chose to. I could have moved that down to here, and I would still ended up with the same angle. All right? So this is law of cosines, law of sines. You need to use that method once on this test, and it'll be for this question if it's put on there where there is no individual angles. Okay? Yes, Cole?
Something I think that would help me personally is a study sheet. Are we allowed to bring those into tests, or like I don't think you've said anything about it.
No, I give you a formula sheet, but that's all you're getting is the formula sheet. So, yeah, no, I don't. I'm going to give you assignments to counterbalance. Like next unit, I'm going to give you an assignment as well as the test. So that's kind of to help you. What do you got to focus on? To answer your question though, I gave you 3 worksheets yesterday or the other day. If you look at these 3 worksheets, all right, you can find the same question on each of these 3 worksheets. So basically what I'm saying to you is there's about 7 or 8 questions that are going to be asked. If you look at it, one of these questions is on each one of these worksheets. So can you guarantee that you're going to see that question? Yes. There's like a curling rock question basically on all 3 of these sheets. You're probably going to see something similar to that. All right? You're going to see the Gardner question is the same as pulling a wagon. You're going to see that question. They're the same. It's not, if you're pushing on a handle or pulling on a handle, it doesn't change anything. All right? What's the other question? There's a rifle question on all 3 of these. There's also a question on all 3 of these in which you have to stop before hitting an object. So if you're driving a car, you have to stop. So you can guarantee you see that. So I'm basically giving you, like, if you do these 3 worksheets, the first one, the second one, and by the 3rd one, it should get a lot easier. It should get a pile easier because they're the same questions. These worksheets, if you get these 3 done, you'll have no problem on your test. If you can do these 3 worksheets and by the 3rd one, get the answers right. They're on here. The 3rd sheet is. The 2nd and 1st ones are on the back, but the 3rd sheet, all the answers are given to you on it. Yes, Brandon?
I was wondering if I could do, I kind of got it right. I'm kind of unorthodox doing this question, but to find another angle using like right angle trig, could you add 60 to 80 up and like get 140 and then divide 80 by 140 to get the percentage? Like, so if you get 80, that's like, it was like 56% of the force went to that side. So then you can figure out that angle is 22.85 degrees.
That's so much extra work.
It's
You just do it like a normal person.
I don't know, it seems easier to me.
Okay,
Does
well,
that make any sense?
yes it does, and I'll tell you why it makes sense. Because when you're using trigonometry, what are you comparing? The lengths of 2 sides. That's how you get your angle. So when you're comparing them, it will be done as a ratio, right?
Yeah.
Well, that's a ratio, that's a percentage.
So could I do it? I find
If
that a
you,
lot
if you
easier.
can find it doing that, the only thing I have to say about that is the possibility is that your decimal places might be off.
Yeah.
But I don't know, okay? But if whatever works, I do understand it, it does make sense to me, that's fine.
Yeah.
If that's easier for you, go ahead.
Yeah, I kind of like it, then you just have the angle ready, you don't have to
Mm-hmm.
get details.
Yeah, well, that's fine. Okay.
Certainly.
Okay. Mm-hmm.
Question 20 on the, if you read the last page of this book, I just kind of forget how to do that. Just do a question.
done this? Did you work on Edmodo? Cause it's been done.
It's all good.
Glad you come back if they already know it.
Did it yesterday. This guy's pulling both weights.
Yeah.
There's your answer. Combine the weights together. Or sorry, I'm looking for this force right here.
But I don't have any acceleration in that question, so.
It's 2 meters per second squared.
No, this is the question for me. Yeah, buddy.
It's 2 meters per second squared.
Sorry, this is the question from.
You draw yourself a diagram.
Yeah.
Here's my plane. The first glider, the second glider. What's the mass? What's the mass of the plane? We don't need it.
The first glider is 1,600. That's only 41. And the other one is 800.
The first glider has a mass 1,600, the second has a mass of 800. But it does tell you the force, does it not?
Yeah.
How much force is being pulled?
We can hold up to 10,000 newtons. So I don't think that's, it just said you can hold up to it, didn't say that's what it was. So I didn't use it. Okay. We'll try the rest of it with that.
But what I did,
Mm-hmm.
I only have 2 things it's pulling. Why is there 3?
It's not. This is what's pulling them.
Oh,
That's your plane.
so I did the mass times acceleration equals force applied, take their force friction.
Is there force applied and force of friction in this question?
Yeah,
Is there force of friction
it's equal to 2,000 newtons on each glider.
on each glider? So therefore, yes, this is not right. Sam, you're right. 10,000 newtons minus 4,000 newtons of friction.
So I got 0.25 there. And my acceleration.
No. That's 6,000 divided by 2,400. It should be more than. You know what you did? No, I don't know what you did.
Oh, 2.5. My answer should have been 320 and I got 3,200. So I see what you're doing.
Okay.
25, not 2.5.
Okay. All right. Lexi, you're fine.
I think so.
Okay.
Thank you.
Cole.
Are we doing our physics test tomorrow?
Yep.
Yikes, okay.
Flying right now.
Like I said, clock sticking. And then the bomb will go off.
Right now.
Is there any other questions here?
Number 2 on page 5 in this booklet.
Or two on page.
I followed this one last night.
Say that again.
Page 5, last page, no, not last page. Yeah, the last
The
page.
truck one?
No, the lawnmower.
Two, three, four, five. Oh, question 2 up there. Okay. On worksheet 3, Morgan, question 2, is that what you're asking?
Yep,
Okay.
I numbered everything myself,
Fair
for
enough.
my convenience.
Alright. Okay. Okay, there's a handle. This is 15 kg. pushing down on the handle with a force of 95 newtons, an angle of 40 degrees. Frictional force between the wheels and the ground is 13 newtons. So force of friction with 13 newtons. Alright, what direction is that mower moving?
I have to say left, forward, because he's pushing the lawnmower to move along.
Sure. Okay, so you're saying horizontally, right?
Yes. Lawnmower's kind of fly.
As far as we know. Alright, so therefore, my applied force is right here. In the direction of the motion. You're saying that it's going to go this way, agreed?
Mm-hmm.
So then you've got to find that force there. So find that force for me. What are you going to use to find it, Morgan?
Right angle tree.
Okay, where is this in relation to your angle?
Adjacent. Hypotenuse. Cosine. 72.77.
Alright. Okay, so now let's look at this. You found out what your applied force was, right?
Mhm.
What do I need here to solve for D and B2?
The acceleration.
So how do I get acceleration again? Not using these. It's got to be that.
The mass. You take the mass and you take the force and you find, you substitute.
Does that look familiar to you, Morgan?
Yes.
Yeah?
Yes, it does.
Okay. So my acceleration is 72.77 minus your 13, and you gotta divide that by 15.
.98.
Alright? So now we're done with Newton's laws, Morgan. We're done with Newton's laws. We don't have to use them. We found what we needed, the acceleration. Now you use your kinematics equations to find D and B2.
And I worked with that quite a bit.
Okay, so what are you given? B1AT, I need to find D.
Yep.
B1AT, and I need to find B2. So each of those, you don't even have to rearrange them now, Morgan. Those, the two equations that you use for this, you don't have to rearrange them. They're ready to go. Okay? Okay, you can do this on your own, I think, now, Morgan.
Yeah, this is the part that I mixed up was well, first of all, the wording of the question did really confuse me. And the second part was the MA equals the applied force take away.
Morgan, this is all you've learned in this chapter. Is that? Net force is mass times acceleration, net force is applied minus friction. That's all you've learned. Everything else is still chapter 2 stuff. And then when you bring the vectors in, you go to chapter 3.
So that equation is like V take away V1 divided by T equals acceleration. It's sort of like that equation. You have to do your subtraction before you
Divide.
get your answer, yeah.
Yes. Yeah. That's right.
Yeah.
Okay. Anybody else? Yes, Petra.
Question 6 on the
Okay. The acceleration of an object is 6 meters per second squared. If the force doubles and the mass triples, find the new acceleration. Okay, so acceleration is equal to force over mass, right? So right now I have 6 over 1. Okay? Because that's what my acceleration was, 6 meters per second squared, right? So there's no like, do you follow what I'm doing now? Okay, so now if you double your force, that makes this what? 12. And you triple your mass, that makes that 3. What is your new acceleration? Yeah.
just didn't understand.
Yeah, the wording of it? Okay. Does that make sense? There's no like, no real substitution into it. I just kind of work my way through it. Get it? That's, to me, the easiest way to do this question. Okay? Anybody else? All right. Keep working then. If you have questions, bring them back here.
Can I go to the washroom?
You may.
Did you see the calculator here?
Yeah, I did actually.
Whereabouts is it?
It could be my desk right now.
You should